Hey, History of Math people. I've had some requests to do some examples of multiplication Egyptian style, particularly some of the exercises on page 51. Before we actually step into an example, let's just go over some terminology. Given the product A times B, A is the multiplier, and B is the multiplicand. Here's A, the multiplier, and here's B, the multiplicand. The Egyptian method of multiplication. Here's the outline, 3 steps. First step, decompose the multiplier, that's this guy. Decompose the multiplier decompose the multiplier into the sum of distinct powers of 2. Can we always do this? For a whole number, absolutely. And the reason I know that we can always do this is every whole number has a base 2 representation. So absolutely we can decompose the multiplier into the sum of distinct powers of 2. It's just the base 2 representation in terms of zeros and ones, essentially. The second step, compute the product of these powers of 2 and the multiplicand. So each of these distinct powers of 2 that add up to give us the multiplier, we compute the product of each of these distinct powers of 2 with the multiplicand, this guy. And it turns out the product of the multiplier and the multiplicand, this thing times that thing, is just the sum of the products that we compute in step 2. Now, why does this work? And we'll do an example or two first and then analyze afterward why it works. Right now, let's do an example. Okay, let's start off with this son of a gun. First, I'm going to identify the multiplier and the multiplicand. This guy is the multiplier, and this is the multiplicand. Okay. Now that we have that established, let's just follow the algorithm. First thing we do, decompose the multiplier into the sum of distinct powers of 2. And I'm going to do this column-wise just for the sake of making it more obvious visually what we're doing. 13.5, let's see. I take the smallest whole number power of 2, that's 1. This is 2 to the 0. 2 to the first. 2 squared. 2 cubed. 2 to the fourth is 16, but that's bigger than my multiplier. My multiplier can't be the sum of powers of 2 that are larger than itself. So 13 has to be the sum of powers of 2 less than or equal to itself. So from these 4 powers of 2, we ought to be able to add them together and get 13. Now what about this guy? Well, this is 2 to the negative 1. Now, let's add the right powers of 2 together to get 13. 8 plus, and we'll start with the largest power of 2. 8 plus 4 is 12, no problem. Now, if we add 2, we get 14. Whoops. This is not one of the powers of 2 that adds up to 13. Let's try again. 8 plus 4 is 12. Scratch this guy out. 8 plus 4 is 12, plus 1 is 13. Hey, that works. So we have 8 plus 4 plus 1. That gives us 13, plus a half gives us this guy. Let's give ourselves a pat on the back. We've decomposed our multiplier into the sum of distinct powers of 2. Now, the second thing that we have to do here, we have to compute the product of each of these powers of 2 with the multiplicand. So we're going to have to take 1 times 2. 1 times 29. 4 times 29. 8 times 29. And 1/2 times 29. And just so that I can fit this all in, I'm going to move this over to the left a little bit. Eight plus 4 plus 1 plus 1/2. There we go. Now I'm going to add up all of these also. No, I'm not. Not yet. I think I'll wait until the grand finale. I think I'll wait until everything else has been done before I add these up. Now, if you saw one of the previous videos, you know the Egyptians didn't have an equal sign, but we're going to put one here just so that we know exactly what's going on here. 1 times 29 is 29. 4 times 29, good gracious, let's see, 2 times 29 is 58. So 4 times 29, 116 maybe. And 8 times 29 is double this, so that's 232. And 1/2 times 29, that's 29 over 2. And that turns out to be 14 plus 1/2. Okay, we've done step 2. We've computed the product of each of the powers of 2 that the multiplier is decomposed into with the multiplicand. 1 times 29, 4 times 29, 8 times 29, 1/2 times 29. And step 3 says that the product of these two things is the sum of these values that we just computed. Okay, let me see. 9 times 6 is 15, 17, 21. 2 plus 2 is 4, 5, 8, 9. I hope. 1 plus 2 is 3. Plus 1/2. This is our answer. 13 plus 1/2 times 29 is equal to 391 plus 1/2. Now, why did all of this work? First, note that we decomposed the multiplier into the sum of distinct powers of 2. If we add all of these up, we get 13 plus 1/2. That we should get 13 plus 1/2 because that's what the multiplier is. And the sum of these things is just a decomposition of the multiplier into distinct powers of 2. So if we add these things up, we get the multiplier. Here we have a common factor of 29, don't we? So I'm just going to write that factor of 29 right here. And when I factor out 29, what do I get? I get 1 plus 4 plus 8 plus 1/2. Tell you what, that's right, but let me do it this way. I get 8 plus 4 plus 1, 8 plus 4 plus 1 plus 1/2 times 29. But what is this? This is just our multiplier, 13.5. So when we add these things up, we have our multiplier times the multiplicand. And this sum is exactly the same as the sum of these things. These are the products of the multiplier. These are the product of the terms that the multiplier is decomposed into with the multiplicand. And we're just adding all of these things up, and what we get is the multiplier times the multiplicand. So when we're adding up the things in this column, we're just adding up the products of what the multiplier has been decomposed into times the multiplicand. And we add these things up, and what we're really adding up is the product of the multiplier times the multiplicand. I was hoping a smoother explanation would come out of my mouth, but hopefully that makes sense. Well, maybe we should do another one of these. Okay, let's do another. 19 plus a fourth plus an eighth, that's our multiplier. 15, this is our multiplicand. Step 1, decompose the multiplier into distinct power, the sum of distinct powers of 2. So we'll write down progressively larger powers of 2. This is the largest power of 2 that we need. The next largest power of 2 is 32, but that's bigger than the multiplier. So 19 expressed as the sum of distinct powers of 2 has to be the sum of a few of these things. It has to be the sum of powers of 2 from this group. And we have a 4th plus an 8th already decomposed into distinct powers of 2. And let's see, we start with the largest power of 2 and add the next largest power. 16 plus 8 is 24. Oops. Nope, 8 can't be one of those. 16 plus 4, we get 20. Nope. 4 can't be one of those powers of 2 into which 19 decomposes. 16 plus 2 is 18. That's good. Plus 1 is 19. Bingo. So 19 is 16 plus 2 plus 1. And we have a quarter plus an 8th. Let me write that down. Next step, compute the product of each of these distinct powers of 2 and the multiplicand. 1 times the multiplicand. 2 times the multiplicand. 16 times the multiplicand. 1/4 times the multiplicand. And 1/8 times the multiplicand. And if we add these up and factor out the 15, what we have is 16 plus 2 plus 1 plus 1/4 plus 1/8 times 15. So essentially we have our multiplier times 15, the multiplicand, which is exactly what we want. Now let's compute our products. 1 plus 15 equals 15. 2 times 15 equals 30. 16 times 15, that's 240. 1/4 times 15 is 15/4, which is the same as 3 3/4. And 1/8 times 15, that's 15/8, which is 1 plus 7/8. And then we just add these together. 7/8 plus 3/4 is 7/8 plus 6/8, which is 13/8, which is 1 plus 5/8. So we'll write down the 5/8 and we'll carry the 1. 6 plus 3 plus 1 is 10. Carry the 1. 2 plus 3 is 5 plus 4 is 9. And 2. Well, here we have it. What is this? It's the multiplier times the multiplicand. So that's our answer. (19 plus 1/4 plus 1/8 times 15 equals 290 plus, wait a minute. No self-respecting Egyptian would leave the answer in this form, would they? No, they wouldn't. (5/8) is greater than a half. 5/8 is equal to a half, which is 4/8 plus 1/8. What was I thinking of anyway? Everybody knows that with the exception of 2/3, Egyptians only use unit fractions. So let me rewrite my result correctly. 19 plus 1/4 plus 1/8 times 15 is equal to 290 plus 1/2 plus 1/8. Okay, that looks much better. 290 plus 5/8, really? Huh. We've mastered multiplication Egyptian style. Let's do division Egyptian style. Before we do, we have to introduce some more terminology. When we take A and divide by D and we get the result Q, the number that's being divided is the dividend. So A is the dividend. The number that the dividend is divided by is the divisor. D for divisor. Pretty clever, huh? And the result is the quotient. The dividend divided by the divisor gives us the quotient. Now, here's how the Egyptians did their division. The first thing they did was they composed the dividend into the sum of distinct powers of 2 times the divisor. So that's division right there. And it's very similar to what we do in multiplication. Step 1, decompose the dividend into the sum of distinct powers of 2 times the divisor. Second step, factor out the divisor. And what we have left is the quotient. Look at that for a minute or so, copy it down, and then we'll do an example or two. Okay, let's try this one on for size. First thing we do, decompose the dividend into the sum of distinct powers of 2 times the divisor. Decompose the dividend into the sum of distinct powers of 2 times the divisor. So let's see, here's a power of 2. And here's this power of 2 times the divisor. Here's another power of 2 times the divisor. Here's another power of 2 times the divisor. Do I hear yet another? Another power of 2 times the divisor. Now what happens if I do 16 times the divisor? 16 times 8 is 128. Oops, that's bigger than our dividend. Now, hopefully, we can get our dividend to 91 by adding up some or all of these things. Let's see. 64 plus 32 is 96. No, too big. That is too big. Let's try our largest product, dividend, power of 2 times divisor, and add the next largest, power of dividend times, take the largest power of 2 times divisor. Let's take the next largest power of 2 times divisor, 16, add them together, we get 80. Okay, good. It's not larger than the dividend. And let's take the remaining power of 2 times the divisor, 8. We get 16 plus 16, 64 plus 16 plus 8 is 88. Okay, so far so good, but we're not there yet. We take whole number multiples of whole number powers of 2 times the divisor, add them up, we get 88. So now we better start looking at fractional powers of 2. Maybe this is just what we need. 64 plus 16 is 80, plus 8 is 88, plus 4 is 92. Oh, we just broke the bank. We got 92. This is too much. But we were close. Let's take the next largest power of 2, 1/4. Yeah, how does this look? 64 plus 16 is 80, plus 8 is 88, plus 2 is 90. We're trying to get 91. Let's take the next largest power of 2. I think this will get us not only in the ballpark, but in the right seat. 1/8 times 8 gives us 1. Yep, this is going to do it. 64 plus 16 is 80, plus 8 is 88, plus 2 is 90, plus 1 is 91. Bingo! We got it. So here we have 91. And notice here, each of these products has a factor of 8. So we'll factor out the 8 and take what's left, 8 plus 2 plus 1, plus a fourth plus an 8, and just for the sake of illustration, let's add these up. 8 plus 2 plus 1 plus 1/4 plus 1/8. Now what we've done so far is step 1. We decompose the dividend into the sum of powers of 2 times the divisor. The second step is to factor out the divisor. Okay, we did that. And maybe we should say here, cancel no. We factored out the divisor. What's left is the quotient. Quotient times divisor equals dividend. Well, what is this thing right here? It's the sum of these numbers in the leftmost column. So let's see what we did. We took the dividend, 91, and decomposed it into the sum of distinct powers of 2 times the divisor. And we factored out the divisor. What we had left was the quotient, and that's the sum of these things in the leftmost column. So let's just confirm our result. 91 divided by 8 is equal to 8 plus 2 plus 1 plus 1/4 plus 1/8. Voila! Division, Egyptian style. One more exercise just for good measure. Divide 87 by 6, Egyptian style. And the first thing that we're going to do is we're going to decompose the dividend into the sum of distinct powers of 2 times the divisor. So here's our first power of 2, 2 to the 0, times the divisor. Here's 2 to the first times the divisor. 2 to the second times the divisor. 2 to the third times the divisor. And 2 to the fourth times the divisor gives us 96. Oops, that's bigger than the dividend. The dividend can't be smaller than the sum of positive numbers greater than itself. Okay, so we stopped here. Let's see how we're doing. This might do it. Let's see. 48 plus 24 is 72, plus 12 is 84. We're getting close. Plus 6 is 90. We were very close, but that messed us up. Okay, what do we have? 48 plus 24 is 72, plus 12 is 84. let's work with fractional powers of 2 now. 2 to the negative 1 times the divisor gives us 3. How are we looking there? 51, 75, 87. Oh, bingo! That is it. Okay. That is it. Let's see what we got. It adds up to 91. And notice that in this column, 6 is a factor. So we're going to factor out the divisor and write down the distinct powers of 2, 8, plus 4, plus 2, plus 1/2. And I'm going to total this up to 8 plus 4 plus 2 plus 1/2. We've done step 1. We've decomposed. Wait a minute. Have I lost my mind? Don't answer that. 51, 85, 75, 87. Oh my goodness. There we go. We've taken the dividend, 87, and we've decomposed it into distinct powers of 2 times the divisor. And here we factor out the divisor. And what we have left is the quotient. Quotient times divisor equals dividend. And what we have left here also happens to be the total of everything in the leftmost column. So let's write our result out. 87 divided by 6 is equal to 8 plus 4 plus 2 plus 1. No. 8 plus 4 plus 2 plus 1/2. Happy multiplying and dividing, everybody.